Welcome, guys. This is the last exercise of first chapter, exercise 1.3, question 1. Convert the following entire surd into surd. So first question we have as root 20, so we have to convert this into another number with another surd which is having a number 2. So this is an entire surd, we have to convert into a surd with a number. We have two methods to do this. First, it's a shortcut method. If we know the factors of 20 and if we know a square number which is a factor of 20, then we could just go on with that number, or else we have to go for a LCM method and find the square number and then do the method. So let's see the shortcut method. So for 20 we know 4 into 5 is 20, so 4 is a square number, so we can write 4 into 5 inside the square root, and we know square root of 4 is 2 into root 5, so 2 root 5. If we do not know that 24 is a factor of 20, then we have to go through the LCM method. So let's see the LCM also. 20 divided by 2 is 10 divided by 2 is 5 divided by 5 is 1. So we have 2 and 5 as factors of 20, and so here we see there are two 2's. So with these two 2's we can say, if we take 4 both together as one factor and multiply with 5, we can get the 2 at last and 2 root 5. So this is the LCM method. Next we have the question square root of 48. So square root of 48 we could say 16 into 3. So 16 is a square number, multiplied by 3 we get 48. If we do not find out this 6, then we have to go to the LCM method. So let's finish this and then let's see the LCM. 16 into 3 is 4 into root 3. So 4 into root 3, 4 root 3. If we see the LCM, 48 divided by 2. 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. And 3 is a prime number, so 3. So here we have 4 2's. So these 4 2's we could divide into 2 equal sets. As in one set we could take 2 2's, and in another set we could take 2 2's. That means the square number is 16, and the square root of 16 is gonna be 4. 2 into 2 into 2 into 2 is 16. So the square root of 16 is 4. This is the LCM method. And next we have root 72. So root 72 we could say 9, but 9 is a factor of 72, but we have to find the biggest square number. More than 9, 36 is big, and it is the square root of 36 is 6. So if we take 9, there will be another surd, that which we could further simplify. So taking 36 is best. Here 2 cannot be further simplified, it's a surd. So 36 into 2, square root of 36 is 6 into root 2, so 6 root 2. If we see the LCM of 72, 72 divided by 2 is 36, 36 divided by 2 is 18, 18 divided by 2 is 9, 9 divided by 3 is 3, 3 divided by 3 is 1. So here we have 2 2's and 2 3's. We have to take the number set evenly. If we take the 3 2's together, then we cannot divide it to 2 equal number set. We have to take evenly to divide into 2 equal number sets. So we will take the 2 2's and 2 3's. So all together if we multiply them, we will get 36. But taking them to one single set, out of the 2 2's, 1 2 would come to one set, 1 3 would come to one set. So 2 into 3 we get 6. All together if we multiply all 2's and all 3's in that red circle, we get 36. 36 square root of 36 is 6. So this is that other LCM, and we'll see the next question. We have root 28. So for root 28 we can get 4 into 7. So 4 is a square number multiplied by another prime number. So we can easily say square root of 4 is 2. So 2 into root 7. So 2 third 7. LCM method, if we go, 28 divided by 2 is 14. Again, if we divide by 2, we get 7. 7 is a prime number and we get 1. So there are 2 2's, and in one set we can get 1 2. So the square number is going to be 4 and the square root of 4 is going to be 2. Next we have square root of 80. So if we go in the normal shortcut method, 16 into 5 is 80. So if we don't know the square number we get 16, we can go in LCM method. 16 into 5 is 80, we know that. So square root of 16 is 4. 4 into root 5, 4 root 5. To find that 16 we can go by the LCM. 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 5 is 1. So here we have 4 2's and we could take them 2 2's to one side, that is 2 into 2 is 4. 2 to the power 4 is 16. 16 is the square number. Square root of that 16 is 4. Yes, we divide them evenly. Next we have 45. So 45 9 into 5 is 45. So 5 is a prime number. Square root of 9 is 3. 3 into root 5, 3 root 5. If we are going to find from the LCM method, 45 we have to divide by 3. 45 divided by 3 is 15. Yeah, 15 divided by 3 is 5. 5 is the prime number. So 2 3's we get. If we divide them evenly we get 1 3. So 9 is the square number. Square root of 9 is 3. So next we have square root of 75. For 75 we can get 25 into 3. Yes, so 25 square root of 25 is 5. 5 into root 3, 5 root 3. LCM, if we see 75 divided by 3 here, 75 divided by 3 is 25. 25 divided by 5 is 5. 5 divided by 5 is 1. As LCM method, we have 2 5's. If we take them to one set, we have 5. So 25 is the square number, 5 is the square root of that number. Next we have 147. So 147 is 49 into 3. It's a bigger number, so if we want we could go on with the LCM method. Now we know 49 into 3, square root of 49 is 7. 7 into root 3, 7 root 3. So if we see the LCM, 147, 3. If we divide by 3 we are getting 49. So next is 7. 49 divided by 7 is 7. 7 divided by 7 is 1. So we have 7 as a set, and then if we take okay, so we can get 7 as the square root in there. Next question. Oh yeah, we are going to the next question. Exercise 1.3. Second question is convert the following set into entire set. So now we have to convert the set into entire set, the opposite of what we did in the first question. So we have to convert this into entire set. It's very easy because now we know 2. To convert it into a square number we have to multiply it by the same number. 2 into 2 is 4. So square root of 4 is 2. So multiplying it with the same number and putting a square root mark, we could say it's the same number. 2 into 2 is 4. Square root of 4, we could say it's same 2. So it's easy. 2 square root of 2 is equal to square root of 4. So square root of 4 into square root of 3 is the number displayed to us question A. 2 root 3 is square root of 4 into square root of 3. It is equal to square root of 12. Root 12 or sir 12 is the answer for A. So here again 2 is there, so 2 will be equal to square root of 4. Square root of 4 multiplied by square root of 5 is root 20, or sir 20 is the answer. Next we have 4 root 7. So multiply by 4 into 4 is 16, and square root of 16 is equal to 4. Yes, 4 is equal to root 16. So if we multiply root 16 into 7, what we get is 7 6 we can get the last number 42. So we place the 2 here and 4 here, and 7 ones are 7. 7 plus 4 is 11. So square root of 112. Next question D, 5 root 2. So 5 we can write 5 into 5 is 25. Square root of 25 is equal to 5. Square root of 25 is equal to 5. So 25 into root 2 is 50. Square root of 50 is the answer. Next we have C, 6 root 11. So 6 into 6 is 36. Square root of 36 is the answer for 6. Square root of 36 is equal to 6. So root 36 multiplied by root 11. So here we can see 36 into 11. 1 into 36 is 36. Another 1 into 36 is 36. If we add them, we get 693. That means 396 we get. 693. So 396. Square root of 396 is the answer for C. So next we have the next question. Second question was easy. Question 3, simplify. We have to just simplify. Here we have square root of 2 plus 5 root 2 minus 2 root 2. So if we have surd, and if we have to add them or subtract them, we can only add them or subtract the coefficient if the surds are same. So if here all the coefficient, not all the coefficient, all the surds are root 2, so we can add and subtract them. If we have square root 2 and square root 3 together, we cannot add or subtract them, but we can divide and multiply them. So we can add only if the surds are same. So coefficient in the sense, we could think root 2 as simply as x. 5x plus 2x is equal to 7x. So here 5 root 2 plus 2 root 2 will be equal to 7 root 2. So simply we could simplify like that. So here we have root 2 plus 5 root 2 minus 2 root 2. Root 2 plus 5 root 2 is 6 root 2 minus 2 root 2 will be equal to 4 root 2. Here all the root 2s are same, so we can place the root 2. 2 root 2 plus 5, 6 minus 2 is 4. Next we can see root 5, 2 root 7 plus 2 root 5 minus 3 root 7. So here we have two different sets. One is root 5 and the other is root 7. So let's see first the root 5. So root 5 is highlighted. So first let's place the root 5. Now we have to find the sum of the coefficient. We have 2 and 1 there. 2 plus 1 is 3 root 5. Next we'll see the root 7. We have 2 root 7s. So here we have 2 minus 3. We'll place the root 7 first and we'll sum the coefficient. Minus 3 plus 2 is equal to minus 1. So 3 root 5 minus root 7 will be the simplified answer. So next question, we have 4 root 3 plus 5 root 2 plus 3 root 5 minus 3 root 2 plus 3 root 5 minus 2 root 3. So there are 3 different sets. First let's see the root 3 set. So the root 3 set, we can place the set and then we'll find the sum of the coefficient. 4 minus 2 is 2 root 3. So next let's see the root 2. The root 2 set, the coefficient we have 5 and minus 3. 5 minus 3 is 2. So we'll place the square root of 2. 5 minus 3 is plus 2 root 2. Then root 2 is done. Next we have root 5. Root 5. So in root 5 we have both we'll place the root 5 first, and let's see in root 5 both of them are 3 plus 3. So plus 3 plus 3 we have plus 6 we could place. So 2 root 3 plus 2 root 2 plus 6 root 5 is the simplified answer. Let's see the next question. D 6 root 11 plus 3 root 7 minus 2 root 11 minus 5 root 7 plus 4 root 7. So here we have just two different types, 11 root 11 and root 7. So first let's see the root 11, 6. So we'll place first the third root 11, and now we'll see only about the coefficient. For root 11 we have 6 and minus 2 as the coefficient. 6 minus 2 is plus 4 for root 11. And next let's see the root 7. So root 7 is having plus 3 minus 5 plus 4. Plus 3 minus 5 we will get minus 2. Before seeing the coefficient, it's better we place the third. We'll just place the root 7, and now we have to see only the coefficient. 3 minus 5 is minus 2. So minus 2 plus 4 is plus 2. So here we get plus 2 root 7. Next, question E. 8 root 3 plus 7 root 7 minus 2 root 3 plus 3 root 7 minus 3 root 7. So the last part we could just cancel off, no? Okay, let's see before that. So here we have root 7 and root 3 as the thirds. Let's see the root 3 first. So root 3 we can place the third. Now we can see the coefficient. 8 minus 2 is 6. 6 root 3. So next let's see the 7, third 7. So I think last two we could just cancel them off. 3 minus 3 is 3. So 0. We would get plus root 7 again. So root 7 we place, and we see 7 plus 3 is 10. 10 minus 3 is again 7. 7 is the one we get, 7 root 7. So simplified answer is 6 root 3 plus 7 root 7. Let's see the next question, number 4. Rationalize the denominator of the following fraction. So to rationalize a number, the last number, the denominator should be rationalized. So if we have something like root 3 in the denominator, it is not a rationalized denominator. Root 3 is not a rational number, so we have to rationalize that by multiplying root 3 with another root 3. So root 3 into root 3, we know we get 3. So 3 is a rational number, so the denominator is rationalized. So let's see the first question. A 2 over root 5. So as I said, we have to rationalize this denominator. If we multiply root 5 with another root 5, we get 5. Root 2 into root 2 is 2. Similarly, root 5 into root 5 is 5. So if we multiply the denominator by same root 5, if we multiply the denominator, we have to multiply the numerator too. So we get 2 root 5 over 5. Yes. Next question. This is how we see that root 5 into root 5 is, we could put them in the same square root. 5 into 5, we get 25. So square root of 25 will be equal to 5. So if we multiply root 5 into 5, we get 5. The explanation is shown in the orange box. And next let's go to the question B, 5 root 3. So if we multiply root 3 into root 3, we have to multiply, if we multiply the denominator, we have to multiply the numerator too. So 5 root 3 will be the numerator, and the denominator would be 3. 5 root 3 over 3. Next we have 5 over root 7. So now we have to multiply by root 7 to rationalize the denominator. If we multiply the denominator by root 7, we have to multiply the numerator also by root 7. So the answer would be 5 root 7 over 7. Yes. Next we can go to the next question, D 12 over 2 root 3. So now we have to just remove the third root 3. We don't need to bother about 2. So we have to multiply the denominator by root 3 and the numerator also by root 3. So let's see here, 2 into root 3. The numerator would be 12 root 3, that's for sure. Now 2 root 3 would be changed into 3. So 2 into 3 would be 6. Oh, before that we could simplify, no? Yeah, so 12 divided by 2, we get 6 up. Again we could simplify. 6 divided by 3 is 2. Yes, so we could just place 2 root 3. There is no denominator. This is the rationalized answer. So next we have 27 over 3 root 2. We have to just multiply by root 2 up and down. So in the numerator we get 27 over root 2 or 27 over root 2 over 3 into 2. So 27 and 3 we could just cancel off. So we get 9. Yeah. Next we can't do anything. So 9 root 2 over 2 is the answer. So let's see the F. 3 over 2 root 5. We have to multiply by root 5 the denominator and the numerator. So 3 root 5 would be the numerator 3 root 5 over 2 into 5. So we cannot cancel anything, it would be same 3 root 5 over 10. The answer. So it's the F. And next we have G, 3 root 5 over 2 root 7. So we have to just rationalize only the denominator. We have to multiply by root 7, numerator also root 7. So in the denominator if we multiply 3 into the thirds will be multiplied together, 7 into 5 we get 35, and 3 into root 35 will be the numerator, and in the denominator we can see 2 into 7. The thirds were multiplied in the numerator, 5 into 7, and in the denominator 2 root 7 were there, so it became a 7, 2 into 7. So we get the final answer as 3 root 35 over 14. Yeah. H, 2 root 3 over 3 root 2. We multiply by root 2 the numerator and the denominator. It will be equal to 3 into 2 is 6. So 2 root 6 over 3 into 2. So 2 and 2 we could just cancel them off. Yeah. Then we get root 6 over 3. Going into the next question, 3 root 3 over 2 root 5. To rationalize the denominator, we have to multiply by root 5. So the numerator also by root 5. This will be equal to 3 into 5 is 15. So 3 root 15 over 2 into 5. 3 root 15 over 2 into 5. So next we get, cannot simplify further. So we just multiply the denominator 2 into 5. 3 root 15 over 10. Yeah. After I we have the next question, the last question, I think question 5, simplify. Yeah, it's also simplify. The question says 3 root 2 into 2 root 3. 3 root 2 into 2 root 3. Yeah, I said we have to multiply the surds with the surd. So we have to just multiply the surds with the surd and the number with the number. So let's see, first multiplying the number with the number. 3 into 2 is 6. So now the surd with the surd, 2 into 3 is again 6, but here square root 6. 6 root 6 is the answer. So B, we have 5 root 11 into 3 root 7. We have to multiply the number with the number. 15, 5 into 3. Surd with the surd, 11, root 11 into root 7 is 77. So root 77. Next we have question C, 5, square root of 5 into 3 root 3. So surd with the surd, square root of 5 into square root of 3 is equal square root of 15. The 3 is as it is. 5 root 3 is square root 15, 3 root 15. Going to the next question, D, 4 root 7 divided by 2 root 14. So we'll write them in the fraction form. So we could just divide the number with the number and the surd with the surd. 4 divided by 2, we can say 2. We get in the numerator 2. So now we will see the surd in the surd. Root 7 and root 14. 7 divided by 14 we know 2. So the square root would come in the denominator as root 2. Yeah, root 2 and there 2. So we see the denominator is not rationalized, so we have to rationalize the denominator. I think we don't need to multiply here the square root of 2 again with 2, because in the numerator we could make square root of root 2 into root 2. So the denominator will be root 2. The root 2 and root 2 will be cancelled off. 1 root 2 will be remaining. Yeah, root 2 into root 2 we can write. So here we don't need to multiply the denominator and numerator, just as the numerator is 2. So we can write root 2 into root 2, cancel one root 2 with another, so we get the balance root 2. So question E says 6 root 2 7 divided by 3 root 3. We can write them in the fraction form. So it's easy. Let's see, divide the numbers. 6 divided by 2 is 3, and now we can divide the surds. 3 divided by 27 is 9. Square root of 9 we get, and there we get 3, and we know square root of 9 is 3, so we could do that also. 3 into 3 is 9. Square root of 9 is 3, so 3 into 3 is 9 is the answer for E. So the next question we have F40, square root of 48 divided by 5 root 3. We wrote it in the fraction form, so we have only the surd with the surd. 48 divided by 3 is 1, and 16 years 1, we get 18, 6. So 16, square root of 16 we know we could write it as 4, no? So root 16 over 5 we will go. 16 over 5 equals to 4 over 5. Yes, root 16 is equal to 4. So 4 over 5 is the answer for F. So we simplified. Oh, we have another question. Question 6 is again simplify. Question A, 2 root 2. We'll see, simplify this. 2 root 27 minus 3 root 3 plus 4 root 7 minus 3 root 28. So here we cannot add or subtract because all 4 surds are different. So but we could simplify these surds. So root 27 it will have some square number as factors, and here root 28 also is having some square number as factors. So we could simplify the surds first. So 2 root 27 we could write as 9 into 3 here. 3 root 13 plus 4 root 7. 28 we can write 4 into 7. So how to convert the 28 into 4 into 7 we learnt in the very first question. So that would be easy. If we cannot find the square number factors, we could go and use the LCM method. So now for 27 we got as 9 into 3. For 28 we got as 4 into 7. So 9, square root of 9 is 3. We get the 3 out of the square root. So square root of 9 is 3. We got the 3 out of the square root. 2 into 3, and 3 would be inside the square root. Minus 3 root 3 plus 4 root 7 minus 3. Here 2 would come out. Square root of 4 is 2, so 2 come out of the square root. So in the square root we have root 7. So simplifying 2 into 3 we get 6 root 3 minus 3 root 3 and plus 4 root 7. Again 6 into 3 into 2 is 6 root 7. Yeah, so now we could see some similar sets. We have root 3 and root 7. Now we could add them and subtract them. So let's first see the root 3. Root 3 we have, so we'll place the root 3 first, and let's see the coefficients of root 3. 6 minus 3 is 3 root 3. Next we have 7, square root 7. Now we'll place the root 7, and let's see the coefficient. 4 minus 6, so it would be minus 2. 3 root 3 minus 2 root 7 is the simplified answer. Next question be 3 root 63 minus 2 root 7 plus 3 root 27 plus 3 root 3. So here we also see the same. There is no similar surds, but we can see 63 and 27 will have some square number as factors. So in 63 we get 9 into 7 is 63. 9 is a square number, minus 2 root 7 plus 3, again 9 is a square number there. 9 into 3 is 27 plus 3 root 3. So if we take the square root of 9, we get 3 into 3 into 3 into 3, then root 7, minus 2 root 7, plus again 3 into 3 root 3, plus 3 root 3. So now we'll multiply those numbers. 3 into 3 is 9 root 7, minus 2 root 7, plus 3 into 3 9 root 3, plus 3 root 3. Now let's see, find the sets which are same. We have 7 and 3. So for 7, let's place the 7 first, and let's find the sum of the coefficient of root 7. 9 minus 2 is again 7 root 7. We have 3 also as a set, so let's place the 3. 9 plus 3 is 12, so plus 12 root 3. 7 root 7 plus 12 root 3 is the simplified answer. Let's see the C part. 2 square root of 128 minus 3 root square root of 50 plus 2 square root of 162 plus 4 over root 2. So 128 would have square numbers factors, 50 would have square numbers 162, and 4 over root 2 here we have to rationalize and then add. So let's see first 128. I think 64 into 2 is 128. It's a big number, so let's see here. 64 into 2 is 128. 2 we could see 64, we got 64 is 8, 8 into 8 is 64, so we don't need to go further, we just finalize 64 into 2. And next we have 25 into 2 for 50. 50, we get 25 into 2 is 50. For 162 again I can see 81 into 2, square root of 9. 162, if we divide by 2 we get 81. 81 is square root of 81 is 9. Can write the 81 into 2. Now we have to rationalize him. We could rationalize him, but we don't need to multiply the numerator and denominator by square root 2, because 4 is itself as factor of factors of 2. So we could simplify easily. 1 2 we could convert into root 2 and root 2. So if we convert them into root 2 and root 2, we could cancel off 1 root 2. So if we cancel 1 root 2, 2 root 2 would be remaining. If we get 2 root 2 would be remaining. So now we got the square root of 64, 8 out, 2 into 8 into root 2. Here 5 we have, we can get 5 out, 3 into 5. 81 we have, we can get the 9 out, 2 into 9, plus we have 2 root 2. 2 into 8 is 16 root 2 minus 15 root 2. 2 into 9 is 18. 18 root 2 plus 2 root 2. So everything is simplified. Not yet. We have now all the third as root 2, so we could just add and subtract them. 16 minus 15 is plus 1 plus 1 plus 18. 1 plus 18 is 19. 19 plus 2 is 21. So everything is set to, we place the 2 and we know the sum of the coefficient is 21. So 21 root 2 is a simplified answer of C. Next D question. Square root of 99 minus 2 root 44 plus 110 over square root of 11. So I think we would be using 11 more in this question. For 9 we have 9 into 11. 99 is 9 into 11 minus 2 into 4 into 11, plus here we have to rationalize. Again we could see that 110 is 11 into 10. So we don't need to multiply the numerator and the denominator by root 11. We could just see root 11 could be cancelled by the 11. So 11 root 11 could cancel. Then we get a root 11 again. The extended form is on. Root 11 into root 11 into 10. So 1 root 11 will cancel and we get 1 root 11. So root 11 into 10, third 11 or root 11, 10 root 11. So 9 into 11, For the next step, square root of 9 is 3, 3 root 11 minus square root of 4 is 2, 2 into 2 into root 11. Next we have 10 root 11. Going to the next step, 3 root 11 minus 4 root 11 plus 10 root 11. So we have only 11 as third. So we will write the 11 root 11, and now we have to find the sum of coefficient. 3 minus 4 is minus 1. Minus 1 plus 10 is 9. 9 root 11 is the simplified answer. So next we have e root 20 over 2 or minus root 5. So it's a small question, but first of all we have to, so root 20 we can write as 4 into 5. 4 into 5 is 20, yeah, and we will have 2 as the denominator minus root 5. So 2 would come out, square root of 4 is 2, 2 root 5 over 2 minus root 5, yes. So 2 and 2 we could cancel them. So root 5 would be the balance. Root 5 minus root 5 is equal to 0.